Okay guys, so in this video I'm going to talk to you about, well, basically I'm going to elaborate on part one of this. Well, it wasn't intended to be two parts, but here it is, two parts, and it's two parts because Mr. Mr. Flavian asked a very complicated question, and I felt that I needed to kind of take that into account when I was doing all of this, so here we are, making our way into the deep end of SOA. So let's get into it. So basically what I'm going to do is I'm going to try to cover this question here in the best, well, there's multiple questions going on here, but I feel like since in part one we were focusing mostly on me trying to get you to understand what the right questions are around, so I'll try to elaborate even further on these questions, because this is the problem, right? The question, how should we split a monolith, is literally as big as asking how should I become a really good architect. Because if you can split a enterprise level application in a well structured, well working way, you are literally a architect. That's what you are. That's what your job is. Your entire bread and butter comes from the ability for you to take a really complicated super system and make it into something that will scale. So let's dive right in. So I've tried to derive a few questions from this text here. So these are the questions that I can pull out from this text here. So how do we deal with keeping models in sync across services? And are there too many if there are too many shared models, an indicator that the split was bad? Is taking into account how the company is split a good start for SOA? And finally, how is DDD related to SOA? So I'm just gonna walk you through kind of how I think about this, and I think that this should be fairly in line with how most companies will and architects will think about this problem. So let's start with the first and obvious question. How do we deal with keeping models in sync across services? Now, this is a big problem. It is one of the hardest things that there is, because this basically ties into API synchronization and being consistent and be with APIs. Now, this is one of the main reasons why I tell people you don't know what you're talking about if you tell people that, oh, microservices is the best way to deal with any architecture, because one of the biggest costs to having a service, any service, it doesn't have to be microservices, is that now you have an external dependency to another system, which means that if we have a look at my tiny little monolith that I've created here, now if let's say that I wanted to get a user here, if this model changes for any reason, then every single client that connects to this endpoint is going to break. Unless I make what we say, unless I do the thing that you're supposed to do, which is to be backwards compatible. And backwards compatible just means that I made a change, but it's okay because it's not going to break existing code. This is a very hard thing. Sometimes you can't be backwards compatible. It's impossible, and therefore you have to do something about it. Now, in normal circumstances, how you deal with this sort of thing is that you either have the option of duplicating the models in two places. In other words, you take service A and you take service B, and then you just make sure that they both have a copy of this model, and then you use something like a version of the endpoint or something like that to communicate to the external client that you're on version 1, and as long as you're on version 1, you can trust that this documentation that I have given you, that usually, hopefully, should be accurate, but most of the time maybe not, it should tell you what you should expect on your side of the conversation or of the call. Now, this is how you probably have done it yourself if you've integrated to Flickr or any of the APIs that you might be using. This is exactly how it works. So if I now change this, I need to bump this version number. Either I need to keep the old version around and like create a duplicate if I'm going to change something about this model and just bump it up to version 2, because it depends on how you look at it. That's the hard part. The second way that you can do this, which is also very common, is to do something like this, which is something that I highly recommend doing unless you want to take option 3, which I will also cover, which is to use a dynamic system, which is something like gRPC. It doesn't have to be Google RPC or gRPC. There are other methods as well. So this is something that you can also do, which I highly recommend for like a project where you're not opting into a very sophisticated solution. If you want to communicate over like HTTP with JSON and all that good stuff, this is a pretty good way of doing it. So what you would do is that you would declare a view model of some sort. Like you have a order view model like this here. As you can see here, all it is an interface with an ID, a user, some products, and then I create order request, which is the request that I send to the order endpoint in order to create my order. Then I have a products model, and then I have a user model. Now, why do I call this user view model? Well, I'm very glad that you asked, because this, my friend, is the V in the MVC pattern. It is the view of the model view controller pattern. Why is this important? Well, it's important because this is the connection, this is the interface and the agreement between my services when they're communicating with each other. It is the thing that I'm going to send over the wire. Now, why would I want to make a split like that? Why wouldn't I just send my raw data? Because some of you know that, oh, the model is my data. Well, yes, this is true. But the problem with just having a model is that the data that you have in your internal system, in your database, may not be the data that you want to send over the wire, because the data that you're sending over the wire might not always be a one-to-one mapping to the data that you are storing in the model. That's why you have a view model, because what a view model allows you to do is to just declare an interface and say, hey, you know what, this is the data that I'm going to send you, and it may be data that's coming from my database, it may be data that I got in turn from another service, like if your monolith has a dependency to another system, you might be in the situation where, oh, I don't have the username, for example. This is a bad example, but let's just say that I don't have the username in my database for this system. I need to go to some other system to get it. Well, it shouldn't matter to the person or the client that is calling my endpoint here if I have this name or not. They don't care how I get the name, just that I have it. And that's the power of having a view. And I've said this in another video. The view, guys, it doesn't have to be HTML. Some people think that, oh, a view is just HTML. No, it's not HTML. It is anything that I send over the wire. Anything that just represent the data that the client needs in order to do whatever it is that they're going to do. So this is a great way. So in this scenario, I've created a monorepo, which is another way to deal with this thing of sharing dependencies. And this works for not just, of course, things that such as the models that are going to be sent over the wire, but also other code. But I highly suggest that if you're going to do a monorepo, this is a fairly simple way of doing it. You simply segment. We're just going to pretend now, because we're going to touch on the split in just a moment, but let's just pretend that these are projects, each of them. Like, they are all servers, and they're all SOA applications. And then all you would have to do is to have this shared directory where you publish all of the models that are shared. And in a perfect world, the only thing that you should share between these different SOA applications is like the minimum thing. You want to have the loosest coupling possible between your services, because the less they know about each other, the more flexible you're going to be. And it's a very nice thing for everybody who's maintaining these projects to just be able to focus on one single external model, like this or like this. Then the contract between the services are really, it's very thin, which is perfect. The less contact surface, the better. Now, you can also, let's say that you don't want a monorepo like this, then you could simply put all of these different SOA applications into their different repositories, and then you could have a shared package, a library that you basically publish to. And that's also something that you could do. You could create a CI pipeline or something like that, so that whenever somebody updates a model or something like that, they simply publish these models, and then they are just pulled in as any, in this case, NPM package. But I mean, this is true for any programming language, guys. I hope you understand that, like, one of the main reasons why I use Node and JavaScript in most of my examples is just because it's very accessible to a lot of people. But most of the concept that we are talking about, these are universal things. Like, every single programming language is going to be able to do this. So these are the main things. And then lastly, I will just mention that there are things that you could do where you can basically generate the client client SDKs type of things, like client libraries from your model, such as with gRPC or similar things, where you create a schema, a text schema, like in this case it's going to be protobuf or gRPC, where you declare a model, and from that model you simply generate the code that is necessary for the different programming languages that you have to connect to your endpoint. So in other words, you would generate a client, like a client SDK or library or something like that, that knows that if you try to connect to this endpoint, this is the data that you should be fetching. And then you could do it that way as well. That is a little bit more advanced, and if you want to go down that route, then you're basically doing it like the big boys and girls at Google and other companies. You can do that. I'm not saying that you shouldn't. I'm just saying that it's for most companies, it's easier to start like this, either with a mono repo or with just a shared package that just shares these different models. Right, let's have another look. Look at the next question. Are too many shared models an indicator that the split was bad? Yes. And yeah, to a point, I would have to say that that's true. If you have, like, this is the hard problem because it depends on how the system is structured. Like, the goal, if I can say that much, the goal of the split should be to create the fewest amounts of dependencies within reason between these different services, because sometimes you simply can't split it anymore. I'll give you an example because I don't want you to go crazy with this idea to try to optimize your code so that there are no dependencies and we live in this pure, perfect, beautiful world where nobody's blocking anybody and it's just beautiful. And I wish I was in that world, but I'm just not. So let's look at my monolithic application here. Let's just pretend we're in Fantasyland. This application has grown way too big. I mean, it's almost 48 lines of code. Holy shit, how are we working like this? So now management comes in and says, hey guys, we need you to split this up because it's taking way too long. And usually this is not what management is going to do. It's some really know-it-all architect or junior developer is going to say that that's going to happen, or a grumpy old senior. Hopefully the grumpy old senior is the person who says it, because then at least they might have an idea what they're talking about. So what our job now becomes is to figure out, okay, how are we going to split this? Now, usually the way that this happens is that there is a feature or there's something that changes within the business, and that ties into this question that comes here. Is taking into account how the company split a good start for SOA? Yes, always. Any architect, and I'm going out on a limb here and I'm just saying, like, literally any. If you have ever worked with an architect who comes in and starts a conversation by saying, you know, guys, IBM, they're using microservices, or Google, they're using microservices. We should do that as well. If they start the conversation with that without stating, but we should probably consider, like, have a look at how our team splits are looking and how our business model is actually working, then they don't know what they're talking about. I will go that far. I will say that they have no idea what they're talking about. Any architecture that does not account for how the business is structured is all but doomed to fail. And that is because it's like theoretical mathematics versus applied math. If in theory everything works, but in practice there are limitations, and those limitations are the thing that is going to get you in when you split something. So if we look at this structure here now, with just these basic models here, I would say that, okay, so we have a user's endpoint where we need to get a user, and then we have a products endpoint where we can get some products and like an array of IDs here that can get us all these products, which is nice. And then we have a post which allows us to create an order. But what's interesting here is that, all right, so the post takes a create request, and then it gets the user and it gets a bunch of products that is associated with this order request, and then we create the order. We create a view model that is a concatenation of like an ID, just a fake ID, a user, and some products, and then we return that view. And then we have an emails, like a self-standing emails thing here. Now, my first thought here would be, okay, I would ask my business coworkers and so forth, like, how is the ownership of this going to look? And they were going to hopefully tell me something like, oh yeah, we're going to have a team that manages these features and those features and stuff like that. And then I'm going to go, okay, so let's pretend that we agree on that, okay, we're going to have one team that is going to deal with the users. That's a very good thing, because if we have one team that is going to own the user's application, that's very nice, because as you can see here, this very simple example only has itself. It only concerns itself with the user model. It has no external dependency, which means that splitting this out means that whoever is going to own that service is going to be able to pretty much, as long as they're not actually changing the interfaces, they're going to be able to ship new features without having to wait for somebody else to do work before they can do it. That's very nice. They only have to really think about, oh, if somebody is depending on us, can we make this change? So that's a nice split, and I actually did that exact split here. So we created a user's endpoint like so. Same thing here with a service layer. We're going to touch on why I think that this is a very nice way. It's something that is very underappreciated, if you ask me, when it comes to Node. Using a service layer like this, guys, as many of you may know, this architecture that I'm showing you is a so-called layered architecture, where you have different layers of the application. And this business logic layer, it's very often forgotten when we're dealing with Node. And when we did this split here, I think that this is a very good time to showcase one of the reasons why I think this is such a powerful pattern to follow when you're dealing with basically any type of enterprise development. So if we go back here and we see here, let's pretend that, we're going to split this out, make it its own service. Well, the logic here is fairly straightforward. We have a user service that gets a user, and then we just send it back, right? Let's jump into that service. So here I have my libs folder, and let's just look at the user model. Like, the user model is a very boring model with a bunch of data, but this also ties in a little bit to the view. Notice that on the user, I have an ID, a name, email, password, address, and created at date. So this is my internal model that we're just pretending right now. This is this thing that I'm storing in my database, and we're just pretending here that, I'm connecting to the database, I'm fetching up all of this data that I'm gonna, like this raw data that is stored in my database, and I'm just gonna retrieve it, because that is what the consumer of this service function is going to want. And then the service function brings up a user like this, and then I map it over to a view model. This view model is the powerful part, because here you'll notice that I'm actually not sending all the data. I'm not sending when the user was created, and I'm not sending the password, because this is information that I shouldn't be sending to the client, and the client doesn't need it. The view model is just as I was saying, the contract between what the client needs and what I'm going to send to the client. I'm not just blindly sending all the data, I'm just sending what the client needs. Now, when I split this out, remember, this is now becoming its own service. It's a completely independent thing. So when it's out, I can just lift out this information, and then the interfaces, like everything just stays the same, and I can go in here and it's still the same. So keep this with you. Everything just was a lift and shift. I moved it out into its separate service, and now it has it. Now we migrated all of the users to a new database. Well, just all of this stuff is just in its own thing. This is in many cases just pretty much the definition of a domain. This is the so-called user domain. It's an application that is now only concerned with the user. For many people, this is also how a microservice should be split. You just split on each domain entity, and that's going to tie into this last thing here. How is DDD related to SOA? So it's not necessarily that DDD is always related to SOA, because and we're going to see that in a moment as well, when we look at the orders, it can be that way. So a domain entity such as the user doesn't have to have its own application. If you're going to split on every single domain entity, such as the orders, the products, and the user, and the emails, then you're actually splitting, then you're creating a one-to-one mapping between your service and a domain entity. And that is very much what microservices is about in many cases, depending on your definition of microservices. But it doesn't have to be that way, and you'll see that in a moment. So I just made this split now because my my stakeholder said that, yeah, we're going to have one team that's going to own the user, because there's a lot of features related to users. Okay, let's move on. Next stakeholder says that, all right, well, we're also going to have one team that's going to handle all the products. Okay, then let's go and have a look at the products. It's very similar. We have a interface for products, and then we have a service that just brings up all those products. Easy peasy, right? And we pull this out, and we just return all of those products. And the same split can be done now as well. I basically lift and shift out all of this code, and when I go in here, you'll see it's basically the same thing. So now I have created another split, so I move out all the products related features into its own SOA application, or like its own service. So now we have two separate things, and these are very good and very clean splits. In reality, it's very rarely that it's this simple, but these are good splits because none of these things are depending on anything else. Everything is depending on them, so they're the leaf in our network of services. But now we come to the orders, and this is different. Because the orders, they are a aggregation, or like they have two dependencies. They are depending on the user service and on the product service. Now they're all using the same interfaces here in my big monolith, so how am I going to do this? Well, by using this service pattern where I have an abstraction layer on top of how to fetch my data, it actually isn't all that complicated. So let's look at my orders over here. So here I actually have two endpoints. I have the orders and the emails, and we were going to talk about that in just a moment. But look here, it's identical code. And then you might be asking, oh, well, surely, Fredrik, you're connecting to the same, you just have a connection to each of these databases underneath. Like you just, the orders service is just going to have one connection to the product service database and to the user service database. No. What we do is that we just maintain the same interface. Well, practically, because here I actually return a promise. And under the hood, we simply trade the direct database call that we have in the other services to have a network call instead. Because it's not important to our consuming code up there in the controller where we're getting the data. We just need to know how to fetch that data and what we're going to get back when we try to access it. It's literally the same thing. The only difference is that in one scenario you go to a database, and then the other scenario you go to another service. This is a very clean way of structuring a scalable application when you want to start splitting things. It's much harder if you combine all of these models that you may see in Mongoose, where you basically litter your controller methods with all of this junk that does all these things, instead of just creating a nice little abstraction on top that keeps it really, really clean. And then you can lift and shift and change the implementation underneath. That's a very powerful feature of having an abstraction. Now, lastly, I'm gonna touch on this thing that you saw where I put my emails over here. So this is the thing where I hope that I can kind of tie the sack on this concept. So is taking into account the company the company split a good start for SOA? Yes, this is one part of this entire this thing that it's so vital, because the email service, in theory, we could have moved the emails into its own service, and then we would, in this scenario, we would have been full microservices basically, but we didn't. And the reason why we didn't is because, as I was saying, there's a cost to having too many services. There's a lot more maintenance, model sharing, and other things that is associated with it. So the business, like me, like as the architect and the business, we came to the conclusion that, well, almost all the emails that we send out is related to sending a confirmation email on when an order has been placed. And since this is the order application, there's really no practical reason why the emails dispatching endpoint should exist in some other service at this point, because the team that needs to touch the emails code the most is the orders team. So the orders team can reduce their dependencies. They already have two dependencies to the user and the products team, which is not ideal, but as I was saying, it's impossible for us to simplify this in a nice way, because we need that data in order to place an order. But at the very least, we can reduce the amount of process overhead by keeping the emails tightly coupled to the orders, because in our business, this is the case. If you're working for Google, this may not be the case, because you might have a really generic email service that handles like email dispatching from tons and tons of, maybe hundreds of different teams that have multiple different products that is in no way really correlated. It's so generic and it's so abstract that it doesn't make sense for some single team that deals with some orders for some specific product to deal with all that extra process around emails. So in this company it makes sense, but in another company it may not have made sense. So what I want you to take away from this is that when you're splitting an application like this, the first thing, as we were saying, is to, if you want to keep your models in sync, that there is multiple ways to do that. The first way is usually, all right, you just copy paste it. You create 2 different repos and you copy paste the models in both places. And then you just agree on that if you're going to version 1 of an endpoint, that's the model you're using. If you update to version 2, then there's a new model and so forth. Second way is that you create a monorepo or something like that, where you can create a shared place where all of the view models that are passing back and forth can live, or you create a shared package which everybody can depend on if you want to have split repos. Lastly, a common way is to use something like gRPC, or I think it's Thrift, other dynamic ways of generating client code for accessing APIs. That's also a way to do it. If you, and as the question indicates, if you have too many models that are going back and forth, it doesn't necessarily mean that the split was bad. It just means that there's a very tight coupling between services. As in this scenario with the orders repository, or the orders application, it has no other choice. It has to get these different connections or to these other services. So just because there's a lot of talk on the network back and forth, that doesn't necessarily mean that you have made a bad split. The bad split is usually where you know that a bad split is usually measured by how unperformant your system becomes, or how much time it takes for you to ship something because you have dependencies to other teams. Sometimes it's impossible to reduce down the dependencies, but you should go for the most sane split for your company. And in this little application, the most sane thing is to give the users their own thing, the product team their own thing, and the orders, they're just gonna keep ownership of the orders and emails, because these 2 different domain entities or concepts are so tightly coupled. And as I was saying, lastly, you always have to account for the company's architecture. The company is there's an old saying stating that the code is a reflection of the company, and that is so true. Any other way would crush the usually the productivity of everybody working at that company. Because if you make a split that works in theory, then then it's going to fail. You have to always have an ideal that you want to go towards, but at the same time be anchored in reality. And in reality, you have different teams who own different things and are good at different stuff, and they have different schedules. That means that you need to split this cake in such a way that they get the piece, ideally a piece that is as isolated as possible. And lastly, how is DDD related to SOA? It's very simple. Usually the way the split an architecture from a monolith up to a SOA level or a microservices system is by doing this exact thing. You identify the different entities within the system, such as orders, users, products, whatever you might have, right? Emails, etc. And then you start thinking of them as different blocks. Okay, which blocks are going to go well with each other? Well, the users, and remember, we're trying to isolate them as much as possible. So the users, well, they don't really need any other blocks or any code it's kind of self-reliant, right? And the same thing goes for the products. But the orders and the emails, well, these 2 blocks, these 2 pieces of logic, they're very related. So let's just keep them in the same application for now. And if the situation changes, well, then we split again, and then we might move out the emails into a separate service. Hopefully this made sense to you. Have a great day.